So welcome to, I think this is the breakout number 15, if I'm not wrong, or is it 14? For ePBS, back from a meeting where we forgot about it. Anyways, I apologize for the last meeting. We have a short agenda today, but it has a couple of interesting discussions that we may have. So the EIP hasn't changed at all, and I'm hoping to change it next week or so, as soon as Stefan tells me that there is an implementation that we can actually test again. I suggest we first start with a client implementation status. Now that Stefan is in my screen, you can tell me something about Teku, perhaps?
Yeah, so I've been running Teku locally successfully and interop with OneNote, and then Enrico today helped me help me test with two notes, and so we're finding a couple of issues, so fixing those. But yeah, it doesn't look too bad. I think we're not far at all from providing an image. Obviously, forward syncing is to be discussed. But yeah, overall should be soon.
Perfect. We haven't implemented syncing yet in Prism either. So and this is part of today's meeting. But yeah. if you can do like gossip syncing, as soon as you have such an image, I'll set it up in Cortosis, and then I'll give you a Prism image so that you guys can test against us too.
Oh yeah, that would be good. Yeah. Right now there are a couple of things which we're fixing, but yeah, I will let you know.
Independently by our image, if you have something to share to run Cortosis, is super welcome anyway. So the first that can have something to share to others.
Okay, so I think Terence is here. We'll prioritize this next week. So by the end of the week, I'll be working on ePBS next week, and then by the end of the week, we should have something that at least should start from Genesis and gossip it. I'll add, there were some situations that we know will break us, like for example, a skipped slot, and then with withdrawals, that would essentially break us because of this issue that we talked last time about, like recovering withdrawals because they're not stateful. But that should be easily fixed. All right, so that's it for Teku. Do we have clients from do we have devs from other clients? I don't see, well, Mark is here, but I don't know if you guys have implemented anything.
I mean, the block processing, the separation of the payload, that kind of stuff, haven't gotten through fork choice or networking. So that would be like
we haven't even touched fork choice either. What we did touch fork choice in as much as to like dealing with missing blocks, but nothing of the fancy thing of like counting attestation, protecting the builder. None of this is implemented either.
Okay, yeah, that's where I'm at anyway, and I've just been trying to understand some of this research around pre-comps and that kind of stuff in the meantime, to try to understand where the road, like where we might be in the next 12 months.
Mark, right. I think you should have enough for a DevNet, even though you don't have syncing and for choice, right? You can just know up the for choice part, and you can just run a local DevNet with what you have.
But no, he needs the P2P though.
Oh, for the gossip, yes. Okay, he doesn't have gossip. Got it. All right.
All right. I don't see Dustin or anyone from Nimbus. So I assume that this is all from clients. All right. The next item in the agenda was Mark, but I think we probably bumped that to the end. And we wanted to have a discussion. I don't see the right person. Oh yeah, you are here. About the Beacon API and how about syncing. Like someone was requesting how the endpoint was going to be. Do you want to lead this this discussion?
Yep, can do. So basically, I've been working on getting the ExpanderOps tooling ready for ePBS, specifically Dora. And I've noticed there are no specified changes to the Beacon API yet. And basically, there is one endpoint needed because as the execution payload is delayed and no longer part of the Beacon block body, we need basically an API to fetch the full execution payload, or better, the execution payload envelope from when it's ready. Should be a simple API under the Beacon domain, just via the block root or something, and yeah, to request that. Additionally to that, it would be also great if we add an additional topic to the event stream to notify toolings if a new execution payload is received by the clients, as that's an async process then. Yeah, I think that's everything I have from the API side that's basically needed to get the toolings up. And
Okay, so for the event stream, I completely agree with, and that should be very easy. Like we just trigger an event for the payload envelope, and we keep the event for blocks as we had before. For the requests, I'm not really sure what's the best path. My original thought was that when we request blocks by range, for example, from other nodes, or when we request a block by root, which we do, for example, when we get an attestation for a block that we haven't seen, or when we get a block whose parent root we haven't seen, we need to request that block for that root. I was thinking originally that for both, we would keep the same API. You just request a block by root, and you request a block range by slot, and we would reply back with the block and the envelope as a sidecar, so all of them together. And if the envelope was missing because that block didn't have an envelope, that sidecar would be just empty. I think this might work for you too, except that if Dora is like just requesting the block by root in real time, then the same request might come empty first, and then later might come with the payload, and you will never know if it was with the payload canonical or not until you make this same request later. So I'm not really sure if like doing this way, requesting the block by root and getting the envelope with it, if you're requesting it for the current slot or the next slot, you might get different answer. I don't know if it's a good, the right answer. Yes, Enrique?
Wait, sorry, just to intercept, I think does Dora use P2P RPC or Dora? I think PK is talking about the Beacon API
Yeah,
for
he's talking about
taking
the
execution by just to have one single endpoint for the Beacon API to get the execution payload. That's it. This has nothing to do with syncing. Yeah.
So
Yeah,
this is only Beacon API. Yeah, we should just have an endpoint that says, give me the payload envelope for this route, and that's it.
exactly, yeah.
So it's much simpler what he was saying.
Yeah,
But to connect to what you are saying, Paulus, about not changing the by root and by range, essentially making the changes very, the most simple as possible. It depends by the implementation, by the way. I was thinking that decoupling blobs and payload, it opens up another situation where the node could become aware of a block without knowing anything about the block itself, all the blobs, and then it just listens to the envelope. So it could request by root blobs and the block itself. Because the envelope has the block root and also all the commitments. So to recover by root, what you need for that slot is, if you just received the envelope, you could do that. So it's an argument to have separated at least by root requests. For the range, I mean, we could have.
So you mean you don't want to get the waste? So you don't want the wasted
read-onload
bandwidth.
essentially the envelope by root. It makes sense in some way because you are close to the head, so you are following the chain. You want to be efficient in that situation.
Yeah, I agree. So and having an option, a Boolean, is it bad design, or I mean, do we want to have a separate endpoint, or do we want to have like a request by root and then a parameter that says give me the payload?
Is a parameter some? Yeah, it's part of the request. So we could the message. So we could add something there.
Yeah, the question is, do we want to have two separate calls? One is payload by root and block by root, or do we want to have one call that has a parameter that says I want both of them together or not?
I would like to have a separate call because then the serialization of it will be tricky because this become dynamic based on what you are requesting. Instead, you can have a type that is tied to the specific request that is you get, and you don't have to deal with am I requesting with blobs or not blobs, and then change the serialization type essentially dynamically. It will be easier, I think.
Okay. Does anyone disagree? I see Terence agreeing with this. Okay, sounds good.
What do we want to do with by range?
So by range, I think we should keep the because when you're requesting
unified.
by range, you're really requesting just canonical blocks. So it's fine to just
but we have separated blobs. Well, yeah, it's kind of weird that we have blobs as separated by range, and then this become unified with the block. In terms of design, high level design. Yeah, we could discuss it this later. It's less important.
Actually, yeah, so I do not know, but yeah, it's true that we're far from implementing this, so we can first implement, check how it's working, and then go back and decide.
It opens more options. If it's probably more complicated to orchestrate the request, but we're already doing this with block and blobs. But then, yeah, you might be interested to get only payloads. Is there a world where this is important? Don't know.
I don't see how for a node that is syncing. I don't see how.
Yeah, and unless this RPC are also used by other use cases.
I don't see how. And but I have another one for you for the other one because we will need this for syncing anyways. Do we want to have like a call for the block, a call for the payload, or do we want to have a call for the block and a call for both together? I mean, is there any situation in which we will be requesting just the payload? I guess if we synced the block and then yeah, that's right. We haven't seen the payload, we sync a block, and then the child comes based on the payload. Then in that situation, we would want to request the payload by root.
I would keep it separated, and you just leave the decision to the client. If you're missing both, he's doing two requests and just one.
Yeah. Okay.
It's much simpler.
This sounds good to me. Does anyone want to take over like the Beacon API for this, both for the endpoint for the API and the endpoint for the RPC request? Because we will need the block one. It's just a simple change. It means you just give me back the block, the beacon block. Actually, there's probably no change because the block is just a new block type, and that's it. And then we need to add one RPC call for the payload by root, and then one beacon API for the payload by root.
I can do that. It's no one is
perfect
stepping up. Okay.
Okay. We took Enrico as a volunteer. That's great.
Yeah.
All right. So is there and this would satisfy Dora already? Is this all you guys need? Just the beacon and the event?
Yep, that should be fine. Actually, Dora should already be ready in a basic way without showing execution payload details, because right now I can't get them. But the basic support should already be there. I just haven't been able to test it yet.
That's very good. So yeah, what would be because I'm sure you haven't done this. If you have done this already, that would be fantastic. Because currently, the Dora would show you the block as either missing or proposed. Like it's either green or orange. I don't remember. But we will need a different status. We will need a different color for a block that has appeared, but the payload has not.
Yep, that's planned then, but I need at least the event for that to show. Right now, it will just show it as missed or proposed without information about the execution payload.
But then this change of having a different status and a new color for it. So do you think it's possible? Do you think it's or it's going to be just too invasive?
Yep, should be relatively simple as soon as we have the event for that.
Perfect. This makes me very happy. Thank you.
I have a question. So Dora also shows, for example, orphaned in a way that continuous block, if it's like it's not missing, it's orphaned, it actually shows orphaned, right? The same will go with execution payload because you can actually reorder the execution payload, right? So we need to show that. Not sure how though. Could be hard.
So this is a new type of orphaned.
Okay, interesting. I'm not that deep into the specs yet. Need to check that out then. Yeah.
Yeah,
But
yeah,
thanks
we
for
can
the
probably take it offline. It's probably yeah.
Yeah, that's right. Because we're gonna so if we have like a separate tab for payload envelopes, then that tab can show this payload envelope was orphaned. All right. So the last topic might be the contentious one. Mark and I think Sean from Lighthouse were mentioning some incompatibilities of ePBS with pre-confirmations. And it'd be nice to know what's the status on that and try to understand if there's an inherent trade-off or not.
Yeah. So pre-confirmations, yeah, that's just been something I've been looking into, and fair warning, like I'm still looking into it. It's not like I understand everything. But just trying to understand what the basic idea is. Now, the existing design of pre-confirmation is in pre-confirmations is in an MEV boost world. I think it's fairly easily adaptable to the current world. So I will, let me see, I'll share my screen a bit. How do I share? There it is. Okay. Well, this shares more than just, oh, that's weird. Did it really just share like a small section? Okay. Hold on, let me figure out how to go back to this. Zoom. My whole Zoom window now went, oh, there we go. Stop share. Okay, now I'll try again. It just shared like one sliver of my okay, so in the design, at least under the current like MEV boost regime, there's like a new entity, basically a gateway, which accepts pre-confirmations from a user and gives them pre-confirmations. And basically what that's doing is restricting the space of building for the builders. You know, in an ideal world, this gateway would actually be the proposer, but it follows the same logic as proposer builder separation, that you kind of need to be a sophisticated entity to be a gateway. At the minimum, you need like some kind of DDoS protection. But I think you would also need, like if you're given pre-confirmations for like a based rollup or something, you would need to have the builders for those based rollups. I would think that you would need to, in some sense, be a builder yourself to be a gateway, just because you're specifying requirements that the block must have, and there's a chance that no builder bids your block. And if no one builds your block and you've given away pre-confirmations, you have to have something to fall back on. Otherwise, you would get slashed for not like honoring your pre-confirmation and missing the block. So in this design, at least, there's this additional, more sophisticated party called a gateway that users are sending their pre-conf requests to. Now, the idea is that proposers register with these gateways ahead of time. And so that like when it comes time for some proposer to have some block, users know where to send the request to because they can look up which gateway that proposer is registered to, and they can send the requests. And wallets would do that. The idea is wallets would kind of do that in the background. And yeah, so the idea is basically like proposer has their gateway. Now, there are some designs too where there's an auction to become your gateway. So basically like some ahead of time auction, like gateways basically bid for the proposer to select them, and the proposer would like in some way select a gateway. And then when it comes time, like users will start sending their requests to it in the slot before. These restrictions on the block are communicated with builders, and proposer still has the final say on which builder ends up winning their block. This can be like adapted in the current ePBS design. Basically, it still requires some off-chain entity to be a gateway. But in some way, the proposer will have to have committed to a gateway, because like the thing about a gateway is it kind of has the right to specify, like the proposer has delegated it the right to specify the conditions on the block, and it needs that. Otherwise, like your pre-confirmations are useless.
So what
Now-
I don't understand of this is in ePBS, the box that is there that says relay becomes the builder itself.
Yeah.
The builder becomes a relay.
So then
And
I would think
I don't
that,
understand why this market of like the proposer committing to a particular gateway or not, why cannot be the fact that the proposer is committing to having his block being built by this or that whatever whitelisted builder is. So I am a base rollup and I want to have pre-confirmations for my rollup. And I say, whomever is a proposer for my blocks in this base rollup needs to be using this whitelisted set of builders. Those whitelisted set of builders are these relays, and they are slashable off protocol in this base rollup. They are
Right.
slashable if they don't honor pre-confirmations. They need to build their blocks from whatever this rollup gateway is, and the rollup
Right.
just sets up the gateway
well,
as an entity, whatever
that's
they
just fine.
want.
That's just fine. Like, you could, I mean, you just have a gateway. You wouldn't have a relay, but it kind of makes it simpler if there's a gateway. Now, if there's just a whitelisted set and they all have to, like, there needs to be some entity that's giving out pre-confirmations anyway,
Yeah,
so-
just the gate. I cannot get away from the gateway. My
Right.
point is that
But
what
the relay can
ePBS
go away.
enables
That
is
is
that this
fine.
market is just
I
it's
mean,
on
this is
between
the
the
same
builders
thing.
and the gateway.
This is still the same thing. It's just that some
Yeah.
entity needs to be given out pre-confirmations, and then the proposer needs to select from a set of builders that are honoring those pre-confirmations.
Exactly.
And so it's fine for the relay to go away here, but you still have a gateway, but that's fine.
Yeah, that's
Yeah.
correct. So I haven't seen yet something that is sort of like a blocker, nor why would a pre-conf team be unhappy with this. But you mentioned something that is an inherent trade-off, which is the gateway
Okay,
cannot be
so-
given break-conf during the time of the slot.
Well, so the issue is like the reason that the proposer has to delegate a certain gateway, is that the only one who can give pre-confirmations is someone who has like the actual rights to build a block. So like I said, ideally it would be just the proposer directly, but yeah, we don't want them to be sophisticated. But all of this kind of off-chain gateway infrastructure is to do with the fact that we don't ahead of time give like a specific builder the right to build a block. Because, and this is what gets into the trade-offs. Now, there are obviously designs like execution tickets that do give a builder the right to build a block ahead of time. The problem with this is that once you know ahead of time that like a specific builder is going to build something, you enable multi-slot MEV. And that's like a centralizing force because it's more profitable to have more than one slot. The math works out that optimizing your MEV for multiple slots, if you have them, is going to be more profitable than the sum of your optimized individual slots.
So Mark, I'll stop you there. I think execution tickets or whatever sort of slot auctions or anything in advance, I mean, this is one of the problems that we have, but we have plenty of problems. We do not know how to implement any of this. There's fraud choice problems. There's a lot of research into trying to implement this. I think this just probably is out of scope for an ePBS call. Execution tickets are far away from being implementable in the protocol.
Okay. Yeah. Well, okay. So, but that was one of the issues. And so like the trade-off that I was mentioning is any construction in which multiple slots ahead of time, you end up with this multi-slot MEV, which is not well understood and which we know is a more centralizing force than what we have now. But like knowing things well ahead of time is really great for execution tickets because everybody knows exactly where to send the request to. And so like if you want to get rid of multi-slot MEV, you need a kind of just-in-time auction. And actually, ideally, what you need is right after the payload for the previous slot is revealed or committed to in some way, the auction for the next slot, or like the builder for the next slot is decided. It's like basically like as soon as the state can be known for what the previous slot is, you want to be able to decide who is going to build the next slot, because then you have the maximum amount of time for that person or entity to give pre-comps. Even if the state of the previous slot isn't known, they could still give what are called inclusion pre-comps, which is just like, I will include your transaction. But there are other kinds of pre-comps like execution pre-comps where not only do I commit to including your transaction, I actually commit to like how your transaction will execute. I provide some kind of state commitment. So if you don't know the state of the previous block, you can't give these execution commitments. So, and it has to happen after that is committed to, because if that decision happens before, then a builder can presumably change their block at the last minute if it's not been committed to, and then they could do multi-slot MEV. So basically it's like as soon as they've committed to some slot, then we have a decision for the next slot. Now, I was kind of thinking about this last night and I had an interesting idea, kind of a hybrid of like execution tickets just around this. Now, where maybe, let me see, I can't really, how do I move this? I'm trying to, maybe I'll just, anyone know the keyboard shortcut to switch tabs? I kind of can't switch tabs because my Zoom banner is in the way. There we go. Okay. Now, I thought it would be interesting if we had a kind of slot auction decided by execution tickets. And I thought maybe there's a way to do this, which is also just in time, because if you have it just in time, then you don't have this multi-slot MEV problem. So The problem with the one of the problems with the standard execution design is that you would rely on the RANDAO to determine which execution ticket won. And we don't have a way of doing like low latency randomness. So basically like you would effectively know the builders that won, you know, an epoch ahead of time, just as you know the beacon proposers in epoch ahead of time. And like that again enables multi-slot MEV, so that's like an issue. But there is like an alternative execution ticket distribution mechanism. It's not like super crazy, but it's just this, it's called proportional all pay, where, you know, let's say you're auctioning off a slot and the builders are bidding for a slot, and each builder puts in a bid and all bids get burned. And basically it works out where like your odds of winning that auction are proportional to how much you paid. But even if you pay more than everybody else, it doesn't guarantee that you win. If that makes sense. It's just this proportional all pay model. And it ends up actually being a little bit more fair because it doesn't mean that the best builder necessarily always wins the slot. And so the construction that I was thinking we could come up with maybe is and this seems to work as long as the proposer is known like 32 slots ahead in advance. But if you had this kind of proportional all pay thing where let's say at block N, you're auctioning off a ticket, or like you're holding an auction for the winner, for the builder of slot N plus 32. And you do this proportional all pay type.
We do not know how to do this, even if you solve whatever it is. That's why I think execution tickets approaches should be kept at a research level and not at an implementation level. We do not know how to solve port choice for that. We just don't know how to do that. That doesn't play well with FFG.
Okay.
We do not know how to add slashing conditions. We do not know how to solve port choice. This is not even mentioned in any of these research papers on execution tickets because no one has tried to implement port choice for that.
Okay. Yeah, I suppose that's just the part that's probably why I'm not aware of this, because I didn't read it in any of the challenges. Yeah, well.
But I do want to talk about a trade-off that you told me, which I think it is a trade-off. So, which I think it is something that may affect ePBS. So I want to have some thoughts on this, which is the following. I don't see any problem in having a gateway and having all of the pre-confirmation today that makes the proposer choosing something. And say when the payload arrives, it's true that you can have a pre-confirm right there and it can be chosen for the next block. And I believe that it's fine if the builder makes that choice instead of the proposer making that choice, because anyways, the builder is going to be the one that is going to have to bid for the next block, and it's going to have to eventually pay the proposer for it. So it's fine if this market of like the gateway being auctioned out is not between the proposer and the gateway, but it's rather between the relay and the gateway, and the relay becomes the builder in ePBS. I don't see any problems with there. However, there is a trade-off that I would want to have the people that study these things look into, which is that there is a time between the block is being committed, which the current spec says that's going to happen at about 3 seconds. And the payload is broadcast, which is about 6 seconds into the slot, in which no one can give any pre-confirmation because the block, except the builder that already built that block. So the builder that already built that block has the block. He can give pre-confirmations for the next slot, and no one else can. So in principle, that gives an advantage for the UX, and that might be a centralizing force for builders. So we want to minimize that time.
Yes, like any just-in-time mechanism is going to have that kind of dark period between when the last payload is revealed and when the builder of the next slot is chosen. And in that period,
that's not the period that I'm mentioning. The period that I'm mentioning is between because we're not even doing a slot auction just in time. The period that I'm mentioning is between the block has been committed in the payload has been committed in the beacon block and that payload is available. That is the time in which a single entity has power over the next, has knowledge of the next slot, which no one else does.
Yes.
And the question is how much that knowledge is valuable. When I talked to builders, they told me that that wasn't valuable because they can simulate a block immediately. However, if we put pre-comps into the game, that knowledge might be valuable because that person can actually give pre-confirmation that no one else can. And moreover, it might even entice the builder to delay the broadcast of the payload.
Yes. Yeah. I was just speaking in general terms, and like I was agreeing with you, but I was trying to speak in general terms, I guess. Because as you pointed out, this exists in MEV boost and this exists in the current ePBS design.
Correct. And I would want to understand exactly what is the time difference, because MEV boost seems to be better for this than ePBS. It's one of those things in which ePBS would make it really worse.
Yeah. And
so
it like I said, I was trying to quantify the time period. The time period is between when the payload for the previous slot is decided and when the next builder is chosen or the next gateway or whatever. So in let's say ePBS, let's say we consider that. So if you're the gateway for some slot n-1 and you know you've been chosen or whatever, you know what pre-comps you've given. Now, granted, these could be made public in some way, but if once the payload is chosen, let's see how do I put this? There's basically a hard deadline in between when the block is chosen, and that's like the attestation deadline, which is 4 seconds in the ePBS or in MEV boost.
Yes.
In ePBS, that attestation deadline is currently set to 9 seconds, but it could be moved a lot closer to like 6 seconds for when the PTC committee's deadline is.
Yeah.
And the issue is like, if you're the builder who's won this and you know that you're competing in a slot auction or you're about to compete again if the builder and the gateway are in like the same entity and they're about to compete again to win the next to be like, let's say, the next gateway. If you're the gateway that has the previous block, then you have information on what the state is that no one else has. And so you can give out those execution pre-confirmations in that dark period.
Yes.
And as far as I can tell, the gap here, the relevant gap, is just the attestation deadline of the PTC committee versus the attestation deadline of the regular block and MEV boost, which appears to be about 2 seconds. So
if we move the PTC to 6, yes, it's going to be about 3 seconds of the dark period, because the payload is going to be committed at 3 and it's going to be revealed maximum by about 4.
Yeah.
About 5, I'm sorry. So it's about 2 seconds.
This does involve like several assumptions, like that the builder and the gateway are the same party,
For the protocol, it has to be the same. It doesn't matter how it goes, because the builder and the gateway will have to have a deal, either with MEV. it's a deal that they already have on commit boost. It's a deal that they have on any design that I know of pre-confirmation. The gateway needs to provide those transactions to the builder, and they have a trusted system in which the builder commits to having those transactions.
Yeah.
So that part, I think it's no change.
But I mean, it's okay if other builders also have some idea of what the state will be, but it's just if you're incentivized to hide it from them so that even if they won the auction, if there's another gateway, actually, really, if there's another gateway that would like to win the auction, but he doesn't know the block for the previous slot because it hasn't been revealed yet, then he can't give execution pre-confirmations because he doesn't know what the state will be.
Yes.
So
and I think that's the question.
Yeah.
I think that's precisely the question. Is this really a centralizing force or not? Do we
Yeah,
have,
and we don't know yet.
The black of like this black box of 2 seconds in which only one entity can be given execution confirmations? Is it really a blocker? Is it something important? This is the thing that I think we need to be quantifying.
Yeah.
On map boost, that time, I think it's about 2 seconds today. So that's why I'm not that worried. Because on map boost, we have actually 2 seconds now. The relay sends the block, has the block at about 2 seconds, and the deadline is 4. So I think it's not changing much. That's why I'm not that worried, but it would be nice to have this from like EF research or people here then to have this quantified well.
Right.
But I think it's the problem became kind of clear. I don't know, we've been talking, the two of us, but I don't know if other people here have comments over this. That there seems to be something that will change. There's this black period of time where only one entity in protocol now has information that no one else does.
And I mean, well, that was always the case, but it's now the case that that information might be valuable.
Yes, correct. So the question is, do we we need to quantify this, and we need to have an idea of what we're facing. We need to know if we want to change it or not. Slot, I mean, remember that exactly this was what killed slot auctions. Essentially the same abstract problem is what killed just-in-time slot auctions. The fact that
what I was trying to mention, by the way, was essentially a just-in-time slot auction.
Yeah, just-in-time slot auction got killed because of that, because the proposer would just delay and just sign for himself.
Yeah. The construction that I was trying to mention, though, the proposer has no incentive to delay and can't pick himself. Because he can't. That's why he doesn't have his incentive. The strange execution, I don't know if it still runs into your fork choice thing, but it was just a way of getting a low latency random number generator where basically the proposer has, like, everyone contributes to entropy. The proposer is the last one to reveal. If he doesn't reveal, he misses his slot, but he would need to collude with all other builders, and you could even mix it with entropy from other beacon blocks so that he would have to even collude with other proposers in order to try to bias the entropy for who wins the auction. But basically his reveal also picks the winner of said auction from 32 slots ago, and he can't make it himself automatically, not without getting collusion with multiple parties, including every builder that is bidded on the ticket and presumably other proposers too, because you could mix that entropy in there.
All right.
And you could give a slot auction because he can't, like, he can't pick himself.
Okay. We should probably bring this into ETH research, or
yeah, I mentioned it to them.
Discuss this at a research level. I don't really know. I don't know how to solve for choice, and as I said, I don't know how to implement any sort of auction in advance.
Okay.
Like, yeah, I'd like to see this in more detail, perhaps.
But yeah, it feels like these are just ideas for because all of these seem to be floating around a lot right now. How do all these interact, the various mechanisms?
So action items for us, besides we committed to having next week images, at least Prism and probably Teku. The endpoint, Enrico committed to put them in the API repo. We can actually implement them. I'm hoping to implement them this week. And regarding pre-confirmations, I think as an auction item, we can take either talk to pre-confirmation teams and see where we're standing, what could be a possible blocker. Last time I contacted them, I think I made a mistake of contacting builders who would be pre-confirmation gateways. And for them, surely there's no difference with the ePBS and these conditions. But Paul from Lighthouse also pointed out that it might not be good for gateways that are not builders. Those gateways might be not benefited by ePBS. And I don't know if you guys have contacts of these people, but I think that's a good action item to mention this thing of the black time that Mark described and talk to them and see if they see a blocker for ePBS. So far, I haven't seen it as a blocker, but I'd like to understand it. I don't know if there's any other action item that you guys can think of until the next call. All right.
Also trying to get in touch with ETH Research to understand more about how these things interact and what they are or what they know about them, because there's a lot.
Yeah, so I have talked to EF Research quite a bit at the design state of ePBS. There's a huge gap between what's research and what's implementable. And at some point, I decided that this is something we can implement in a safe manner today, and it doesn't need more research.
Yeah.
So I'm happy to implement anything that is safe. If there is a better design that is safe, I'm happy to implement it. But so far, I haven't seen anything concrete.
Like if anyone does solve execution tickets, this will move us closer in that direction. Yeah. Just separating the payload and the block, which is actually a lot of work. So
correct. That I think is my objective. And if someone solves the auction mechanism in the meantime, that's fine. We can just quickly change it.
Yeah.
All right. So if that's it, we can probably close here. And so hopefully for next meeting, we will already have a 2-client kurtosis run. Is that correct, Enrico and Stefan?
Yeah, seems very plausible.
Yeah, it could be.
Okay, perfect. So that'll give us a DevNet. I think this is good news. So for next call, we're gonna do this. So in the next 2 weeks, that's our objective, to have a 2-client kurtosis run. Perfect. And we might even get Dora to show us the blocks. Perfect. All right. All right, guys. Thank you very much. Thank you all for coming. Thank you, Mark, for describing this issue.
Yep.
And I'll see you in 2 weeks.
Yeah. Bye, guys.
Bye.
Bye-bye.